Hello and welcome to a demonstration on how to set up the Advanced Process Optimizer, or APO. After installing the software, you'll be able to pull up the interface as you see it here using your web browser. And in the menu under Wizard, Setup APO, you will find this wizard, consisting of 9 steps in which to set up your plant, historical data, the goal you want to optimize, and some reporting functions. The purpose of APO is to create a mathematical model for the process in your plant, given some historical data that characterize that process, with the aim of giving you practical, real-time suggestions on which tags to alter in such a way that a certain key performance indicator is maximized. And what that KPI is entirely up to you to choose. It must be computable from within the tags in your dataset, but could be financial, such as profitability. It could be physical, such as yield or efficiency, whatever you choose it to be. Now, to create my model, I first create a plant to hold the dataset. I want to create a new plant, and I'm going to call it Algorithmica with the company, and I could insert additional fields to make it more specific. As this interface allows me to have multiple plants, I might in general want to be more specific as to where my plant is coming from. And if I have any custom code that the company Algorithmica has written for you, this is where your custom code ID would go. I'm installing here a standardized test set, so I don't have any of that. The second step is to enter my tags. Now, there are 2 ways to enter the tag information. One is in this form, in which here I could say, for instance, I have 208 tags. I would add them, and then I would get an empty form of 208 rows, and I could fill in this information by hand or by copy and paste from externally. However, there's a second way of doing it, which is to prepare the data in advance, save it in a text file, and then upload it. And that's the way I'm going to choose to do it here. This is the upload form in which I first pick the plant, which has been correctly chosen to be the plant I'm working on at the moment. And what do I want to do? There are several choices of whether to upload the tags and the data freshly, that means deleting any present information, whether I want to update the present information, or whether I want to ignore this or that. So at the moment I want to upload both the tags and the data freshly for the first time, and I've prepared the tags file and the data file externally, and I'll show in a different video how to prepare this data. For now, I have these 2 files. The data file is in the CSV format, and so I can press Upload. The Upload button then does several things. It first uploads both files onto the server. Then the tags file is parsed to be checked for correctness. If anything is incorrect in the file, that will be flagged to me. The tags are created in the database, and the data file itself is then also parsed, but because that is usually a bit more time-consuming, that is done in the background as a computational job. And all of my computational jobs are listed under Jobs here, and if I open that link in a new tab, I can see my jobs. Currently, I have 2 jobs running. The data upload job I just started, which is currently being computed. It has been started at this time. And I have a statistics job running, which will compute the statistical information of that data for display in the interface. And of course that is queued because it's waiting for the upload job to finish and will then be dealt with after that. And at the end of both of these jobs, there will be finish times over here, and I can proceed back to my form to work more on my dataset. A few minutes have passed, and as we can see, both of the jobs have completed, and successfully so that we can go back to our form. The next thing to do would be to introduce some validity rules. Now, the purpose behind this is that some of the data that you have uploaded in history might not be suitable for learning. In developing the mathematical model for your process, we want to only look at data that is truly characteristic of normal operations. We don't want to learn data, for example, where the plant was off, under maintenance, or some kind of not normal productive conditions. In order to isolate or to throw out the data points that are not normal, we have these validity rules. If every validity rule holds, then the point is valid and therefore learned. If any one validity rule is not holding, that point is thrown out and not considered for learning. So I'm going to select tag number 1 to be added to my list. I can choose when this rule is going to be applicable. I can make that dependent upon another tag having a certain value, but I want this one to hold always. So the rule is always that my tag number 1, which is the rotation speed of a gas turbine, is between, let's say, 500 and 10,000 RPM, which means that if the speed is less than 500 RPM, the point will be considered invalid and not learned. Going to save that, and that's enough for here. Next are the correction rules. Now sometimes you find, and a particular example might be a valve, where a measurement is below or above the usual measurement range for that tag, but it's still a legitimate value. So valves, for instance, are either open or closed or somewhere in between, and often that's measured in percent. So 0% means the valve is completely closed, and 100% means the valve is completely open. Nonetheless, you sometimes find that you measure -1% or plus 102% as being the state of the valve. While it's physically impossible to have these values realized, nonetheless the numerical value sometimes is like that, and we have to correct for it. We have to say this valve is going to be 0% open if the numerical value is less than 0. And so we look for this value here as well. Tag number 172 is exactly such a valve, and I'm going to say that if it is less than 0, it should be equal to 0, and so you see the rule is being read like this. If tag 172 is less than 0, then tag 172 will be equal to 0. That effectively prevents any negative values from occurring in practice. Having entered all my corrective rules, I go to the next page, which is to check plausibility. Here, several simple plausibility checks are implemented by the software to check if my data set, my original settings for the tags, my validity and correction rules and so on make sense given the historical data I have. At this time, it says the model is plausible, which means that every check that the software has internally here has yielded a good answer, and I don't have to make any corrections at this time. That does not mean that everything will be perfect, because after modeling, we will need to go back and to check some of these validity rules, some of the correction rules, and some other things to make sure that our output is correct. And we call that a fine-tuning process. There will be a separate video covering the fine-tuning process. For now, we will go on and define the goal function. In the goal function, we can define what is the key performance indicator that we would like to optimize. At the moment, there isn't one defined, and it goes like this, that the function is an addition of several terms, each term being the multiplication of a factor and two tags. The idea, for example, is that if you want to model profitability, then you have several items of revenue and several items of cost built up in such a way that the first tag would be the physical value, for example, volumes or weights, and the second tag would be its price. So many dollars per kilogram or whatnot of material that you have in there. The factor would act either as a +1, -1, depending on whether it's revenue or cost, or could be used to transform units. If you had, for example, the amount in kilograms but the price in dollars per ton, then you would have to convert kilograms to tons, and that could be the use of the factor. So in this case, I'm going to add one row to this, and I'm going to have no modification, just a single number 1 as the factor. I'm going to take any particular valve, and I'm going to keep the second tag empty. I can write a comment here. This is just for my own bookkeeping purposes. This will have no effect. And so I just type something here. I save my changes, and that is my goal function. I proceed to the modeling process. First of all, we want to model this plant that we've just created and uploaded data for. That's correct. The method is a full recomputation. There isn't any information to be deleted at this point because the plant is new, but we could also choose a model only, in which case previously made suggestions would be kept. We can use a time limit if you want the modeling process to only start at a certain historical date. Typically, we don't use this time limit because if you didn't want to model in those historic dates, you wouldn't have uploaded that data. But anyway, for convenience, that function is supported, but it is by default off. And if we click on Model, the computational job of doing the mathematical modeling is added into our jobs queue and will be processed in the background so that I can still continue to interact with the web-based interface here while the job is being done in the background, and I can go back to my jobs queue, refresh that, to see that the APO product has been given the task of model and apply. Here, this job has started at this time, and now we have to wait for it to finish to go back to our form and continue our work. Having waited a few minutes for the modeling job to complete, as we've seen here, we can now go back to our form, go to the next stage, and compile the report. The report will be for the plant we have just created. We want to look at it monthly, and it will be over the entire duration to which the beginning and the end points are initially set anyway, and we want the report over the whole period. So we request the report, and here's our report giving us the overview of the potential. Now here we have month by month named the number of suggestions that were given during that month, and for our goal function, the potential as compared to the measured quantity, that is, on average, the 18.7 could have been improved by a 5.2. So that's a very significant increase in that value. Lower down, we can see some of the common suggestions. The tag 192 is in 100% of all suggestions. The average change is 5.8. The tag 174 is in 89% of all suggestions, and its average change is to be lowered by 0.05. Gives you a summary of the goal function that we have agreed on, and the validity and correction rules that were implemented before. Here are the two we've added. And lastly, gives you an overview of the potential over time. That reaches the end of the APO setup wizard. You now have a fully set up plant with a model ready to be used, and the next step would be to fine-tune that model, a process which we will cover in a separate video. Thank you very much for your attention.